Hello, everyone. Welcome
Hey, guys.
to another episode of Eigenbros. Terence is, you can tell by his voice, he's
a little bit bummed right now.
He's a little bit sad because, I think, I thought it was recording, but apparently it's not. So
the video's not recording.
The video's not recording, but the audio is recording. So if you, we actually kind of go into a lot of different topics, mainly opening up with cold fusion.
Mm-hmm.
Talk about thorium reactors.
Mm-hmm.
Then we talk about pseudoscience in general.
As
a concept. And then we talk about a review of Top Gun, the movie.
Mm-hmm. Yeah, that's pretty much it. You hit the nail one. I'm glad you took over there because I'm still kind of pissed off now.
He's not pissed at me. He's pissed at himself.
I'm pissed at myself for that f***ing amateur-ass move. But anyway.
It's upsetting because he has to go back. If you go back to the old episodes, it's kind of reminiscent of like...
Well, don't give anything because I don't even know what I'm going to do yet. But older episodes where I misrecorded, you can see. Yeah,
but don't worry for those audio listeners. Mm-hmm. You're still getting our sweet voices into your ears, into your canal. So, if you haven't already, subscribe, follow us on Twitter. At Eigenbros, TikTok. TikTok's probably dead right now.
Yeah,
TikTok
canceled now.
Yeah, so but follow us on Twitter. TikTok, but Eigenbros 2 on TikTok.
And Instagram Eigenbros. Yeah,
so Twitter's a constant, so we're more popular on that. So go follow us on that if you haven't already.
Yep.
And and stay for the show.
All right, guys.
3, 2, 1.
Howdy, folks.
Hey, welcome everybody to another episode of Eigenbros.
Yes, indeed.
Today it's going to be off the cuff, I guess.
Off the cuffish.
Yeah. I know last week we were like hinting at like what was it? I think you wanted to mention something about cold fusion.
Yeah.
And honestly, I know nothing about it.
Yeah, it's actually a kind of interesting story. To be honest,
because to me, when I think of fusion, I think like Dragon Ball Z, fusion,
Gogeta.
Yeah, or like Asian fusion kind of food. You know what I mean?
Jazz fusion.
Jazz fusion. Thank you. Yeah, all these cool fusion techniques. You know, maybe like, you know, when you go to didn't soda companies, they mixed sodas for a while.
Yeah,
it's the same thing. It's like fusion.
Those new machines. Well, not new, but the advanced kind of soda machines.
Oh yeah,
that
the
have
ones
like all those flavors.
Advanced, yeah.
Yeah, those basically do the mixing.
Yeah.
That's how you can get all those flavors because it just mixes them in the machine.
That's also a form of fusion, in my opinion.
Yeah.
So
lots of fusions that are not relevant at all.
So when I think cold fusion, I think it's kind of a bad name because it's like, what does that even mean? Cold fusion.
Yeah.
Because typically everything else in physics is kind of like it means something.
Well, it does too.
Okay.
Physicists have really simplified names. So cold fusion is basically as opposed to hot fusion, I guess you could say. Whereas hot fusion would be how fusion is done in the sun. Mm-hmm. Where basically, how the sun is basically just a giant ball of gas.
Yeah.
I think it's hydrogen. Maybe it's got some other constituents. I'm not an astronomer, so I don't know. But
it's mostly hydrogen, I think.
I think mostly hydrogen. And of course, as you get just a giant clump of hydrogen in space, I mean, the clump is so giant that essentially gravity is just smashing those hydrogen atoms in the core so powerfully that eventually they just fuse together, and then you get a reaction or a release of a lot of energy.
Yeah.
And that's a fusion reaction.
Mm-hmm.
And apparently fusion produces more energy than a fission reaction.
A fission reaction?
Yeah.
What's a fission reaction?
So a fission would be the other form of nuclear reaction where like it's the one that we use in nuclear bombs where instead of fusing the atom, you split the atom.
Mm-hmm.
So when you split the atom, you actually get less energy than if you fuse two atoms together, which to me wasn't very that really intuitive.
No.
I would have thought the other way around where, splitting the atom gives you more energy output than fusing them together, but apparently it's the other way around.
Interesting. Why is it?
I'm not sure. That might be a deeper question. I don't know for sure. Nuclear is. I took literally maybe one semester in undergraduate of nuclear physics, so I don't really know that much. But fusion I know is kind of the predicted wave of, like, what would you say? It's the predicted wave of how we'll get, this big surplus of energy in the future if we ever do, reach that goal. Fusion is kind of the what is it? The holy grail, I guess.
The goose egg.
Yeah, the golden goose egg. Yeah,
for physicists to make themselves relevant, I guess. Right, or to make themselves useful, I guess.
Right. But cold fusion is interesting because it's basically fusion where you won't need high temperatures. So, in the case of the sun, one of the reasons that it even fuses is not just gravity, it's also the fact that it's just so hot. When things are so hot, they're vibrating at this high rate.
Right.
And then eventually they just vibrate so much to where they're smashing into each other. And that heat is basically one of the constituent parts of a fusion reaction. And cold fusion would be a type of fusion without that heat, that necessary high temperatures. So some fusion reactors like the tokamaks out there, like ITER.
I have no clue about. I don't know anything about fusion. Like I said, it's like Asian fusion. I literally know nothing.
But the classic fusion reactor is the one that's got the it's got the little donut shape, and then there's like a plasma gas inside of it, and they use magnetic fields to confine the fusion part or the plasma particles. You have to use high temperatures for that one. Because eventually to get the plasma, you have to strip away the atom to where it's just constituent electrons and protons and whatnot. It's like a soup.
Gotcha.
So you need really high temperatures. With cold fusion, though, the idea is to have some kind of fusion with either room temperature or low temperatures. So it's kind of interesting. How much do you know at all about cold fusion?
I know nothing.
It's like a conspiracy guy territory concept, though.
That's why I kind of stayed away. I'm like, that seems kind of.
Yeah, I came in the kind of the same way. I know for a fact when you hear cold fusion, physicists are just face palming, and most physicists will not take you seriously if you're talking about cold fusion. But it was interesting, man. I learned that cold fusion was actually a concept that was taken seriously back when it first came out. Which is why there's like asides in movies about cold fusion being a legit thing. Like, I don't know if you saw the most recent remake of Wall Street with Shia LaBeouf. No. Well, in the Wall Street movie, Shia LaBeouf was like investing in cold fusion or some shit.
Oh, that's funny.
And I was in undergraduate physics at the time when I saw it, and I was like, really? Cold fusion? This movie's dumb as hell. But I didn't realize it actually had origins of something.
Wait, who's
real.
in that movie? Is that famous guy?
I want to say Michael Clark something, or Michael Douglas or something. Douglas. Is that it?
Yeah.
I can't remember exactly.
He has like such a distinct voice, too. It's like
yeah.
Michael Douglas. Michael Douglas here.
Greed is good. That's his
he had that famous speech, right?
Yeah.
Greed.
It's like pretty much the zeitgeist of the 80s condensed into that one scene.
Yeah, it's that it's kind of like that ABC, it's like ABC speech that what's his name? One of the Baldwin brothers says in that movie. Alec Baldwin said in that movie.
In Glenn Ross.
It's that same thing.
Yeah.
Always be talking about cold fusion.
But man, the cold fusion stuff is pretty interesting. Two chemists are the ones that actually came up with the concept. One guy named Fleischmann, the other guy named Pons. Fleischmann was an older dude.
Pons?
Pons.
Any relation to Ponzi schemes?
It might be fitting because he's pretty much
in the territory of wacko and physics now because of that whole charade with cold fusion. But Pons was the student and Fleischmann was the mentor. Pons was a fan of Fleischmann's work and basically signed on to his lab. And it's cool because Fleischmann did some research in palladium. And apparently palladium is really absorbent of hydrogen. So it absorbed like 900 times the amount of hydrogen or something when it was placed into a hydrogen bath of some type. And he was like, whoa, this material is really weird and it absorbs hydrogen so much. So then Fleischmann and Pons teamed up and had this weird idea to make it so that they had the thought that if you can absorb a lot of hydrogen into a small area, then they wonder if the atoms can get so close together that they basically squeeze and squeeze to where they actually fuse. So that's the whole concept behind it. So then they made this weird electrolyte, like this like a fusion cell.
So what really happens? Like, is that like the nucleus? Like the hydrogen atoms would bind to the nucleus of, like,
what would
you know,
be the actual chemical process?
Proton, because the proton would it merge with the nucleus of the frickin' palladium atom or something?
You mean like how's the chemical process go?
Because it seems like, you know, you talk about two, you know, in the physics models, right? The toy models that we have, it's like the Coulomb interaction. Like you have to have such an immense amount of force to bring these two basically atoms together that might be, you know, the force is proportional to the charges squared.
Yeah.
I assume you can use this for any charged particles or charged particles in general.
For Gauss's law?
No, for Coulomb's law.
Coulomb's law, yeah. Sorry.
Yeah.
Any charge.
But I'm wondering if it's like, if they're neutral, does it still matter?
The electromagnetic force to overcome that?
Yeah, because like you can bring in you can bring a charged particle to a neutral atom. You should be able to do that, right?
Yeah, I think the electromagnetic force becomes less relevant when you have two neutral particles or something.
Yeah, this might be just me thinking out loud.
Yeah, it's fine though. I mean, it's a good thought, right? Because you're like, how can you overcome the electromagnetic force, right? Because that's a strong thing to overcome.
Yeah, it's repulsive.
But I don't think they even made it that far. These are literally chemist guys who didn't really know that much physics, and probably why they got in so much trouble with this area.
Oh, okay.
So I think they just had an interesting hypothesis and wanted to test it out. Because you know how experimental physics goes anyway.
Yeah.
Sometimes when things make sense in theory...
well, I mean, it's an interesting thing. Like, if palladium absorbs hydrogen like that, it might prompt you to ask, like, why?
Yeah.
Yeah.
But being experimentalists, they said, well, let's just see if we can even make this thing. So instead of using straight up hydrogen, though, they used deuterium. They used deuterium. I'm not sure why.
Probably because it's cheaper, let's just say.
Not even sure. I wouldn't imagine it's cheaper.
Let's insert some fake news out there.
No, let's not, because I don't think it will. It probably wouldn't be cheaper. I imagine normal hydrogen is more prolific, but I don't know. But the thing is, they used heavy water. So they made an electrolyte cell, a fusion cell. I don't know if you ever played Fallout, but they had fusion cells for their plasma guns and shit. And they made a fusion cell with palladium and platinum. So I imagine one was an anode and one was like a cathode. And an electrolyte solution they had where it was basically heavy water, and they ran a current through that heavy water, and it allowed the solution to basically separate into deuterium and oxygen. So then when it separated into deuterium and oxygen...
So deuterium, for those that don't know, is H2, right?
It's actually just H, but it's... Oh, H2 as in two isotope? The isotope? Yeah, I guess you're right. I'm not sure how you would class that, because when you say H2, I think of two hydrogens. But deuterium is just hydrogen with a neutron. Yeah. So... the deuterium gets absorbed in the palladium, basically. And Pons and Fleischmann measured 100 times increase in like the temperature or something, which wouldn't account for just some normal reactions. So then they said, oh, voila, we've made a fusion cell. There, we've done it. But then, of course, you know how that goes. One experiment is not enough to really corroborate that. So then they had a guy...
so they rushed to publish.
They tried to, but... they couldn't. They wanted to do some more research. I think they just maybe published a preliminary result or something. And another guy, I forget his name, I think it was Jones maybe. He was a Mormon, or I don't know if he's a Mormon, but he taught at Brigham Young University. So I assume he's one of those crazy religious guys. I forget what it is.
Okay.
But he was a nuclear physicist and read the Fleischmann-Pons preliminary result or something. And he was doing some interesting work related to it. but he's on the physics side. So he said, let me measure the number of neutrons coming out of this thing. And he measured a surplus of neutrons, but not anything that would come close to a fusion reaction. But then this freaked out Fleischmann and Pons. They basically thought Jones was going to scoop them. So then they started to do all this careless stuff. They were going out to the public trying to lift up their results and kind of exaggerate them and say how they basically created a cold fusion reactor or cold fusion cell. And they were just going crazy with it, with their claims. And they kept trying to do all this stuff to kind of circumvent the natural scientific process because they wanted to publish the research. But while Jones was actually trying to get in with them to help them by doing some measurements on neutron
collaborating stuff, so that they could really suss out what's happening, right?
But then eventually I think he gave them an ultimatum, was like, I'm going to publish these results, like if you guys, they denied him.
Whether you want to or not.
Yeah, like they denied him to work with them because I think they wanted the credit all to themselves. He said basically like, I'm going to either publish this or you guys can work with me and I'll give you till this amount of time and then we can publish together. And they said, all right, we'll accept, we'll publish with you and you can help us with this research. But then of course Fleischmann and Pons did a little conniving shit where they published, they accepted his offer, but then they published earlier.
Ooh.
Yeah. But then they published all this flawed research and basically this was like the beginning of the end of their
like the Brigham
stuff.
Young guy, he had to do it to him.
Yeah, he had to do it to him.
He looked in the mirror like the Birdman meme, and just rubbed his hands, had to do it to him.
Well, I think he gave him a really reasonable offer.
That's beyond reasonable.
Yeah.
It's like,
but they just got caught up in wanting to be the founders of fusion.
Yeah.
These two chemists with no physics background. That's a slight shot at the chemists, but
poor saps. Just
and they published all this really faulty research, and people kept trying to replicate their results and findings, and they just found one thing after another.
Yeah.
One experiment after another just kept turning up false results.
I wonder if that's why after that they probably started making chemists take quantum mechanics
because of Fleischmann and Pons.
Yeah, I'm not even kidding. Like
that would be hilarious.
It's like I have friends that took they call it PChem for those of you that don't know, like physical chemistry. And the buddies of mine.
Quantum.
Yeah, there's basically quantum mechanics, and they have to basically learn quantum mechanics 1, the fundamentals, right? They go through the same, like they talk about S&P orbitals and how they get to those, and hybridization, what that looks like in the physical picture, yada yada. They have to do all that, which is like hilarious. Which makes me think that
Fleischmann and Pons.
Yeah, which makes me think, but they probably made him do that because it's like you have to have some rudimentary sense of quantum mechanics to know what the hell you're talking about at that point.
Holy crap! My stopwatch has been going on for like days.
Oh dang! No, you're good. There's a little timer here we got.
Yeah, what's the time?
Don't worry about it. It's down there.
I can't see it.
16 minutes.
Okay. Yeah, let me just start
But yeah, that's kind of wild. I didn't know anything about it. Like I said, I had no clue. I don't know any of the history. I almost like I don't even, nuclear to me is something that's like, oh, this is it's such a specific field in physics, right? I'm sorry to say, but I have zero interest in it. Although it's really cool. Yeah. I mean, the only time I ever really got into it was when people were talking about those what are they called? Thermo something reactors?
Thermonuclear reactor?
No. Dang it. I'm blanking on the name. But they were like hyped up because they use salt. They use like a salt or something. Instead of using like some kind of radioactive material, it's like it's a very cheap like alternative. Thorium, I think it's thorium.
Okay, yeah.
Yeah.
The thorium reactor was like a big thing where people kept saying, why aren't we using thorium reactors?
Yeah,
I think we even wanted to do an episode on that. I don't know why we didn't.
I don't know anything about that either. I remember reading about it and then being like, okay, that's kind of interesting. Why isn't anybody investing in this? It might be the same thing as cold fusion, though.
Yeah, it could be.
Because it's like they keep making it sound like a conspiracy kind of deal. I'm like, we would use a better energy source if we could. So, like, I don't know why we're not.
Yeah.
There must be more to the story.
Like, the profit motive should be enough to drive some cunning investor to, like...
Right. There's no grand conspiracies that we're not going to use a better energy source if we have the available...
Cheaper, better.
Yeah, like if it makes sense to.
Yeah.
Right.
Now, unless it's like the whole Elon thing where, where he saw the grand vision of using reusable rockets, where like the existing infrastructure.
Yeah, but the thing is, the reason we didn't do that is not for the fact that there's a conspiracy not to do it.
No, I know, but that's what I mean. It might be
Okay,
the thorium situation might be analogous to this.
That's what I think it could be, because usually things, if they're like better, the thing with your comparison with Elon Musk is it's a giant barrier to entry of money, and then also a giant barrier of unproven concepts. So that means you're going to have to invest a lot of time, money, and energy into just even seeing if it's got a proof of concept. And no companies want to be wasting millions and millions of dollars on something that might not even pan out.
It's got to be your own money, which is what Elon did.
Why Elon was able to do that. It doesn't make sense for an industry to do that kind of stuff.
It could very well be that thorium is probably this, maybe.
That's what I'm thinking too. It could be a whole re-architecture of the nuclear reactor.
Yeah, because then you might have to change the architecture.
And then nobody's like, no one wants to invest that kind of time or money or energy into redesigning a nuclear reactor.
Yeah.
But maybe, in the future there could be.
Yeah, true. And then people there's already a negative connotation with nuclear energy.
Yeah.
In the mind's eye of the public. I think this is boomers specifically. I think
you're right.
Hate to be so reductionist and like ageist, but
yeah, I think because during their time was when all the nuclear scares were
Cold
happening.
War stuff. Yeah. So they hear nuclear and they flash back to those PTSD moments where like in school the alarm went off and they had to simulate like getting under their desks. Nuclear alert. It's like,
nuclear holocaust is imminent.
Yeah. The Russians are landing. Yeah, man. That's wild. I'm pretty sure. I hope that our generation, because I feel like the latter day millennials, right?
The latter day millennials sounds like a religion.
But you know what I mean? Like the we're on the tail end of of the millennial generation, right?
Right.
And
we're boom millennials, or
yeah. We're the bygone, like we're basically like we're the people that carry the torch into the new generation. We're the bridge. We're the bridge to the Gen Z. We have some Gen Z tendencies.
Mm-hmm.
But
you're a little closer to the Z than I am, but
yeah, I am. But still, like it's kind of like we were born on the internet. We're more accepting of the integrating the internet into our lives.
Yeah.
As opposed to maybe some older millennial groups.
Sure.
But yeah, I think our generation might be open to this.
Well, I think the older millennial groups, I think mostly the difference between Z and millennial is social media.
Mm-hmm.
I think a lot of the millennials, even our age, are a little bit more versed to social media platforms.
Mm-hmm.
And I think that's going to be the real separator between your generations in the future, is the whole adeptness of your social media game.
Yeah, because like I see a lot of I feel like I have social media wisdom in some sense.
Yeah.
Because we were born in the era of like, chat rooms and stuff and like forums and not sharing private information and then all this other stuff and then going into MySpace where you had to take embarrassing photo angles just to,
Yeah.
Luckily the servers were deleted and everything.
So you think.
I would like to go back. I like those timestamp things of like looking to see where. I wish I kept
cringe,
mine.
Bro.
I wish I kept.
I don't want to go back.
My page wasn't that cringy when I left it. I was like, oh, there's some cool stuff on there.
Mm-hmm. You may think that, but then you'll see something and be like, damn.
Yeah, I guess so. But yeah, it's. I think our generation has that sense of we kind of, how would I say this? We don't have a portfolio.
Yeah.
By luxury, because there's all these. Well, I don't know. Maybe the TikTok kids too are going to be. They're kind of lucky in this sense because I just heard TikTok is going to get deleted or something.
Yeah, I heard that from
the
Trump,
servers.
but I don't know what that's going to entail.
I don't think you can. Right? It sounded like legal. Is that legal?
To ban a platform? Yeah, you can. If it has if you can justify why.
Oh, national security issues.
I think it has to do with China. China's access to data.
Yeah.
Yeah, I would imagine you probably can do
Yeah.
it somehow, especially if it's like an espionage tool for China or something.
Yeah.
I don't really know the details though, but we'll see.
Trump's like, the Tootsie Slide is a Chinese psyop. I don't trust it. No, it's a Canadian psyop. I'm sorry, I said that wrong. Yeah, but yeah, it's kind of silly like that they're doing that. But yeah, like the Gen Z might get lucky in that sense where they
won't stop it though. It'll just push them to a new platform.
It will.
It'll just be like the exodus of the Viners, where they all just went to YouTube, right?
Yeah, or
Yeah.
Snapchat.
Or Snapchat, yeah.
Or a different version of TikTok, where I think I was watching a Gary Vee Instagram the other day, and he mentioned 2 platforms, Dub Smash and Thriller, which are basically just 2 different iterations of TikTok.
Yeah, they're almost identical.
So I'm like, oh, okay, that's what probably would happen.
We'll see what happens with that. But yeah, we were born in that era, right? We were born in that demographic where we're kind of lucky in the sense that a lot of information was kind of scrubbed from the internet. Like we're almost, as opposed to like people who have their whole they have a whole like digital footprint of their existence on the internet.
Right.
But yeah. Anyway, back to thorium reactors.
Yeah. What about thorium reactors? They're
No, yeah, it's just something that I hear is like should be adopted more. But yeah, that's something worthwhile looking into. Maybe we could see why it works and why it doesn't work. I think we hinted at it a long time ago in one of our early episodes, but
yeah, who knows though? Who knows? We'll have to look into it more. Maybe we can do an episode on it.
Yeah, because it's like because you hear stuff like that and you might get into like pseudoscience kind of stuff.
Yeah,
and like. I know you kind of mentioned something about that too. You were like
about talking about
pseudoscience? You mentioned some pseudoscience.
Yeah.
Stuff.
So one thing I was thinking of today, it's kind of interesting. It's just a kind of a random thought, but I was just thinking, we do all these videos on pseudoscience topics, and we get a lot of commenters on our like alien UFO conspiracy type videos. And I was thinking like I feel like we have a good knack for being able to sift through bullshit and pseudoscientific topics.
Okay.
Which I think a lot of people don't have that luxury. I mean, some people have the luxury of understanding how to string logic together and things like that, and to maybe even see, use their intuition or read things maybe in a non-calculated way.
Okay.
By just noticing patterns. But I was like, I wonder how you can kind of chronicle ways to sift through pseudoscientific topics in a realistic fashion, because when we run across certain papers, right? Like let's say if you ran across a paper online that was on like high level nuclear concepts on like let's say you were reading a paper on quasars, like a high level astrophysics paper on quasars. Like me and you, 2 condensed matter physics guys, could be so out of our element that how do we tell that against bullshit versus something that's just really high level?
Yeah.
And I was kind of thinking, like, what is it that we can use to tell that stuff? And then there's a lot of it that you have to rely on, as in what kind of is familiar in some sense. So one thing I notice is, if you're looking at a paper on quasars, you try to look for things that you recognize or that you're familiar with already at a more basic level. So like you would look for, like, let's say with quasars, you would look for equations on energy or something. Or we would look for graphs and figures on things that kind of make sense to us and try to follow those conclusions. But, once you start to get kind of outside, like let's say if you're going to look at a math paper, like a math proof on some weird esoteric math concept, I think I wouldn't be able to tell. I don't know if I could confidently distinguish that from a complete bullshitty pseudoscience or pseudo-mathematic concept.
Yeah, math is tough because it's built on such a big framework of, like, because the terminology there. I think physics is even astrophysics paper or something might be a little bit more attainable in terms of.
Maybe so, but I'm trying to think of what would be a really esoteric physics concept that's real that we would have a hard time.
You talk about high theory then.
What is it?
You're talking about high theory then, like string theory or
Yeah,
something.
yeah. Oh, yeah, there you go. Like a string theory paper.
Yeah.
I wonder if we had a side-by-side of two papers written. One is a crank paper and one is a high-level physics paper. I wonder how well we would be able to distinguish between which ones are bullshit and which ones are real.
Well, that's a problem currently, like just a problem in general with the peer review system. Like they've done studies on, they've done studies about this. It's almost like a stress test of the peer review system. They put out, there's certain publications that, not publications, but there are certain groups that put out test papers that are bullshit. And
it's like secret shoppers.
Yeah, legitimately. And yeah, it's all like jargon, and some will get accepted.
Wow.
Yeah,
just because of their name too.
Well, just because of their name and their status. So like
yeah,
this happens a lot with like higher what do you call it? Like higher education institutions that are prominent, like
Harvard,
MIT, Harvard.
Yeah,
I
can see that.
They'll get the pass just because of the name.
Yep.
And a lot of the lesser institutions kind of get pushed to the side because it's like, everybody look what MIT is doing.
Right. Especially if it's more fringe type work, because then they're just like, oh, it's just a shitty no.
Well, I mean, like
university.
all this science and publication journals in science publication journals is all cutting edge stuff.
Yeah.
So a lot of it's going to be bullshit for the most part, I think.
Yeah.
Well, not bullshit,
or it can
but
be questionable. Like things may not pan out even to be useful.
Right.
Yeah.
Yeah. A lot of the stuff could be miscalculations, and there's some corrections that need to be done. There's always stuff like that where it's constantly being adjusted and all this other stuff.
Right.
But yeah, there's a famous I think it was like an AI generated. It's an AI that generates papers, scientific papers. It takes in the base knowledge of a certain field and then it like cranks out a paper, and they managed to get, I think, a couple of these papers through to some journals, to the chagrin of those scientific journals. Yeah, but just because it sounded legitimately, and then the peers who reviewed the papers, they must have felt totally embarrassed.
Yeah.
But a lot of these guys, like, so the way, for those of you that don't know, the way the peer review system works is that, at least in our specific field, is that you're handed, if you're submitting your work into a journal, they are assigned, your paper is assigned to 3 different professors or research scientists in the same field, and then or same subject if possible, and they pretty much critique your paper, editorializing maybe a little bit, if they don't really understand what you're saying, maybe saying like, you should add this, or this is not convincing enough. Stuff like that. But I think like what happens is when you get to these higher institutions, it's harder to criticize like some of the things. Like for instance, for me, in my particular branch and study, we have qualms with a certain type of technique that we run into a lot with my advisor, and that's called ARPIS. Angle resolved photo emission spectroscopy.
Okay.
Yeah. It's the way the resolution works with the system, but it's like you can get discerning, you can get models that tweak the variance in like the let's say the metric of unit that it measures. Here it's energy, but if you adjust like the energy levels to the certain thing, it can change the system in a dramatic way, like
in a non-negligible way.
Way, yeah. So it's kind of like but people take this ARPIS data stuff as like
gospel.
Yeah.
Because we see that a lot in science.
Yeah.
Like this is a common thing with p-values, for instance. Like people think the p-value, once you have a good p-value, that says everything. But it's like,
so to people that don't know, what's like a p-value?
So I'm not even sure exactly.
It's like a statistical thing.
It is, because we don't use it. Like
we don't.
Me and you don't. I think it comes within the chemistry community, and I think even maybe biology or something. But you see p-value stuff all the time, and there's just so much controversy that surrounds it.
I'm pretty sure it's close to what the regression, kind of like analogous to the linear regression, the R value.
R value, yeah. I think it has something similar to do with
it's
that.
It's like how your function fits the data.
Yeah, but you see people abusing the p-value a lot of times, just with how they arrange their data. And yeah, you get these kind of things a lot of times, and also you get this a lot too with more indirect measurement techniques.
Like,
I've noticed.
What do you mean?
Things that measure things indirectly. Another one I remember is frog. So in a group I was working with when I was undergraduate for a internship, they were having some disputes with frog because frog is this way to measure like the pulse width, I think, of a light wave.
Okay.
Well, the pulse width of some kind of wave. I can't even remember now, really. But it uses this indirect measurement technique where it uses like another wave to measure the other wave. And there's some weird indirect measurement you get from it that makes it so it's not as reliable. So when you get like more and more separations between the measurement, that's when the technique also comes into question a lot of times. I've noticed. So I've seen that usually one of the best ways that people love to get metrics or to get
data experimentally is using frequency measurements.
People love frequency measurements because you can get counts of things. Like, for instance, the cesium atom is used to measure the time of an atomic clock. And that's literally because the cesium atom does like X amount of transitions from an excited energy state to a lower energy state. And you can measure each of those times it switches. So you can get an exact value of how many times it goes between those energy levels. So it seems that frequency measurements get a lot of good
respect in the experimental community. So
one advisor even that I talked to, one of our instructors was like, if you want to make a good experimental setup, use frequency in your measurement somehow. So it's just interesting how certain experimental techniques are better than others.
Yeah.
And some are even frowned upon depending on what they are. And if you have a bad experimentalist or if you have someone who's kind of doesn't know what they're doing many times, then they can use the wrong experimental techniques or unnecessary ones when they should be using better techniques.
Yeah, when they're more if you're trying to make a point, there are better tools to make a convincing argument as opposed to
Yeah. And this kind of reminds me of a guy. You ever heard of Nassim Taleb?
Yeah, sounds familiar.
Yeah, so Nassim Taleb is this really interesting guy on Twitter. Wait a minute. At least I see him on Twitter.
Did we do a video? Is he one of these guys that we covered on one of the pseudoscience guys?
No.
Oh, okay.
No. Nassim's a legit guy. I don't even know what he is. I think he's some kind of scientist. But I follow him on Twitter.
Social scientist?
No. He's a legit hard scientist, whatever it is. Either math or physics or something. I would assume just by his rigor.
Gotcha.
But he's an interesting guy because he's like basically a bully of nerds. He's basically a nerd bully who basically is on Twitter that calls out people who do bad statistical analysis or data analysis, and he just puts them on blast, whoever it is, and just shows them. He calls them IYIs, intellectual yet idiots, and basically breaks down why their measurements or whatever they've done is wrong or inaccurate.
Jeez.
And he calls out everybody. One of the bigger ones I knew him from was when he said he literally would not go on any podcast that Sam Harris is on. So he's a big problem with Sam Harris. I'm not really a big fan of Sam Harris either, but I just thought it was funny that he won't even do a podcast if
why?
Someone has done one with Sam Harris. I guess he just doesn't respect him as an intellectual. So
gotcha.
I don't know what he did. I'm sure maybe Sam Harris got under his nerves with some poor analysis he did or something. But Nassim Taleb is an interesting guy because he basically chronicles pseudoscience by showing all of the bad examples that people have done in the scientific community over time. Yeah. And he's pretty well respected within the community. people just don't like him because he rubs people the wrong way by the methods that he uses.
Yeah, basically shaming people.
Yeah.
This is why I was like...
It's like the cancel culture of intellectuals.
But that's why I was wondering if it was like a social scientist, because this doesn't really happen in STEM. Like, cause it's like in STEM, it's handled on court in a sense. So like, it's like you duke it out in the over emails or something. Like, it's not really over social media.
Yeah, it's an unusual tactic, but
yeah.
I find it entertaining.
It is. I mean, if you want to,
I like his style of doing it because he literally can break it down in a reasonable way. Mm-hmm. And I kind of like, I think we do need some more bullies in science.
Yeah, you do need to.
Nerds got to get called out sometimes.
Nerds got to get stuffed in the lockers. It's the natural.
It's necessary.
It's a circle of life. Okay. Yeah, we've all been there. I think. Intellectuals do kind of get hoity-toity kind of they need to be humbled sometimes.
Yeah, they need to realize that even though they think they've gone to such a high level of understanding and they have all these tools at their disposal, they need to remember that you can have all these tools and things at your disposal, but if you're still doing things in a dumb way and you're analyzing things improperly, you need to get called out for that lack of rigor.
Yeah,
like you got to change it.
No, but you also run into this issue that I think there was a paper, not a paper, it was an article written by Feynman back in the day, but it was called like something with cargo cult science or something like that.
Never seen it. You want to care explain?
Yeah, it was just like he's saying that we got to be careful as scientists to not fall into a pattern of it was basically bias confirmation in some way. Like he took this example of a tribe in, I think, Peru or something. I think it was in South America. Mm-hmm. Anyway, or Eastern Asia. I don't really recall exactly, but the point is, it was like an uncivilized part of the world, meaning that they hadn't had the luxury of modern like civilization and its technologies yet. Mm-hmm. So whenever they would see like biplanes or like planes fly over and stuff, they would try to hail them down. Like they would get cargo. The local people knew that the people on the planes, when they saw cargo, that they would come and they would come and inspect, because I think because typically I think the cargo meant that you had people that were part of your like squadron. I think there was a war going on at the time. I don't recall exactly, but anyway, the people would line up the cargo in such a way to make it look like it was like a landing strip so that the planes could come and land. So they were being clever, but it wasn't. They would do everything right. They would try to get it to look exactly like a landing strip, but still some of the planes wouldn't land because they knew. So his analogy to it was like these are people nowadays doing science. They're doing everything like the scientific method, but they're trying to do a sort of confirming biases in some way.
Yeah, they keep doing like the same kind of techniques and things just because it's been proven to work in some certain instance, and then they abuse that technique in areas where it doesn't apply. Yeah. Right? Just because they know the strength of it in other areas, it doesn't apply for certain things.
It was a badly worded paper too, because he called it cargo cult science, and you're like, what is he talking about? He should have called it something else, because it's an important message to be read. I think every scientist probably needs to read it, just to kind of be aware of that at least, or be weary of it. And but yeah, it's poignant. If you have time, go read it, go check it out. It's made available to the public, I think. So
interesting.
Yeah.
So I guess the moral of the story is, at least for me, when I try to approach some new topic or some scientific thing that I'm trying to prove, or
try to have your bullshit meter like go off.
Well, no, I'm just talking about if I'm doing science. I think the simplest and most direct approach is the way to go, as much as possible. So if you're trying to figure out something experimentally, go with the simplest method and the most direct method. I think that could be a useful axiom to have.
Yeah. I think in general that's probably the smartest way to do it.
Yeah.
Yeah, I mean most papers nowadays, like good papers that are written, give you a decent introduction and then go into like the more advanced things, and you can sort of build, depending on the relative difficulty of the paper in terms of like the mathematics or the rigor, you have to reproduce equations, you have to do all this stuff to make sure that you get what they're doing.
Yeah.
And at least in physics, but yeah, it's but typically it's very readable. A good paper is very readable, and people understand where your connections are being made or how they're being made, and yeah. So, I think shitty papers, I think bullshit papers kind of leave things to be rather vague.
Yeah.
And like don't really like provide, I hate to say bullshit papers, but because there's some papers that like you're pushing the boundary on certain things of understanding, and it's like you don't know, so you're just like I don't know. But yeah, I think it's using bad. It might have to do more with like doing bad analysis. Probably.
I see.
Yeah, that's probably the best way to put it. I wouldn't say like bad analysis, meaning that you're the how would I say, like your statistical modeling is poor or something like that, like it's like you're not making a convincing enough argument, like maybe like the Pi paper, right?
Oh, Pice?
Pice, yeah.
Yeah,
Like
Pice gave me that same feeling. He gave me a feeling of I just felt no satisfaction from it in any way. It just felt the feeling it gave me. It's so funny to be talking about papers in terms of feelings, but it's actually weird because you kind of have to have that. Yeah, you have to have this weird impression of what's good and what's bad in some strange way. When you have nothing else to work on, if there's no logic to really work with, which is what Pius's paper was, there's no real evidence to work with.
The problem
I have to go with impressions. Almost.
Yeah, I think this is what the biggest thing is, because with Pais, for instance, like he should have shown some kind of even theoretical calculations or data
that I can logically go through and actually be able to see the path.
Plot this shit, right?
Yeah.
Plot whatever dependent variable is required, and then like what it should look like, how it should behave, because we need to have a sense of what this is.
For the people who are unfamiliar, Pais is the guy who we did a couple videos on related to the UFO patent technology.
Yeah. So this guy is a physicist who works for the Navy, right?
Yeah.
He's a PhD
aerospace, engineering or something.
Yeah. So he's got legit credentials, and he's publishing some really interesting stuff, to say the least.
Interesting is a stretch of a word. Maybe
curious
things.
Yeah, curious stuff.
Things that prompt you to look into them.
Yeah.
But the actual content of them it leaves you desiring much.
Yeah, but I can see why you're kind of lingering on the pseudoscience stuff, because it's like, we're reading into these kind of things.
Yeah.
It's like,
and I think it's a really important skill that I think a lot of physicists don't develop very well. I think people are so scared of being called cranks or being called dumb that they actually don't spend time investigating pseudoscience. And for me, that's a very important thing to actually spend your time on, because in order for you to be able to quickly distinguish what's a time waster or not, you actually need to understand what kind of common tells are out there for pseudoscientific topics. And that starts from just first impressions to feelings, and then to the actual logic. The logic is very clear cut, but if you can get a good sense just from the impression, sometimes you can cut away the time you waste on a particular paper.
For instance, this kind of goes to Malcolm Gladwell's. I read this book a long time ago. I think it was like 15. And there's like Malcolm Gladwell's first book, I think. It's called Blink. And it's about Blink. It's about first impressions. It's about how
critical.
It's about how the psychology of that, because the psychology of gut feeling, especially for experts. And the way the book opens up is, and this, I was at Target with my mom or something, and I was just like,
just reading it.
I was just like, yeah. Well, she's shopping. I'm just gonna read the prologue of this. But the prologue was so interesting because it opens up with this art buyer, I think, if I remember correctly. I have to recall.
It's probably a long time ago.
We're talking over a decade. So, it opens up with the art collector. He hires this expert, or a number of experts, but this one particular expert with I think this one person had the most experience. Comes in, spends 2 seconds looking at this model, this art. What is it called? Like the
statue?
Like the statue, yeah,
Sculpture?
like a sculpture. Thank you. And he looks at the sculpture for a couple seconds, is like, it's fake, and then he leaves, cashes his check, and
I could do that.
But it's literally like it took other people, much, like, people couldn't get an impression. They had to look at the technical details. They were like, it looks real. But this one guy who knew the body of work of this one particular sculptor was like, that's not their work.
Right.
And it's like the impression, the immediate impression the guy got is like, this is a bullshit thing.
Yeah.
And the whole book tries to explain this one thing.
Interesting.
This one feeling. This one impression.
Yeah, it's very hard, right? It's almost like you got it or you don't in some sense.
It's strange.
And I think it becomes more and more stronger the better you are at seeing those patterns on what are the tells. But I don't know if you can, maybe you can quantify it, but it's hard because...
Yeah, this ties into like the 10,000 hours shit.
Yeah,
exactly. But yeah.
But I think most people just don't have the time or the energy to chronicle that kind of stuff.
No.
But I think this is very tied also closely to intuition, right? Because like when I listen to, I've listened to so much classical music, like for example, like Mozart or Bach or Beethoven, I can almost, I wouldn't say 100% of the time, but 90% of the time I can tell if it was done by Mozart, if it's like a classical composer who does a similar style.
Yeah.
I can tell if it's Mozart or not without even knowing. And then when I look, I can see, yes or no.
Gotcha.
There's a certain thing that you can see with it, but I don't know if I could actually quantify what it is. And it has to do with, just like you were saying with that Blink novel or book, is the impression of it somehow.
Yeah, it's very powerful stuff. It takes the power of first impressions, but it ties closely to our bodies do this, or our minds do this this quick calculation.
It's been honed over millions and millions of years.
Yeah, because it's like it's an intuition that's built in from like it's almost like modern man has adapted it to specific things. So like it's almost like a fight or flight thing that's built into us already, that we kind of our neocortex may be hijacked in some way.
Yeah.
Where it's like, oh, we get a gut impression about this, and like, is it, is this fake or real? Is this is this a threat or not? Like, kind of thing. It's
right.
very
in the past, you didn't have time to be wasting to see, is that a saber tooth or not?
Yeah.
It's like, if it's a saber tooth, you're dead.
Yeah, if you're thinking about it.
Time.
Yeah, if you're thinking about it, you're.
It's too late.
It's too late. So yeah, it's that. By the way, that book, I recommend it to everybody. It's a super interesting book.
Did you wind up buying it?
Yeah, but
okay.
Convinced my mom to buy it. I didn't have any money. Yeah, I read the whole thing. It was very good. There's also another interesting part in that book that was kind of that left an impression on me that was crazy to me, that I couldn't believe. That this one psychological study where they looked at couples. They looked at married couples.
Okay.
Yeah. And non-married couples, but they wanted to see if they could tell if relationships were going to last just by first impressions.
Right. I think I might have seen this where they checked the responses that the couples gave to each other based on like problems or something.
Yeah.
Yeah.
This is that famous study. And they done follow-ups, and it's actually kind of remarkable how accurate it was at like, I think it was over 50% for sure. I want to say 70% accuracy or something insane.
It's a statistically significant result.
Yeah, I can see that for sure.
Just within like 2 or 3 seconds, people were able to judge this couple is not going to last.
Right.
Like it was like, wow. The mind does these like quick snap judgments that are so powerful. And so first impressions are everything.
Yeah.
It's really interesting how there are these hidden like underlying tricks that give a high yield of accuracy that we still are cataloging and trying to understand.
Oh,
It
the
just shows
things
you
that
how-
our mind does?
Yeah, and how
Yeah.
optimized the brain and our environment actually is in some weird way.
Yeah, we don't have access to all the fucking stuff going on in here.
Yeah. I imagine one day we could, but I think it just would take a lot of understanding.
Yeah, I think you have to. It's also a part of awareness, right? Because it's being aware that we do these snap
Yeah.
judgments and being aware that people do generally get first impression, or they base everything off of first impressions.
Yeah, I
So-
think, yeah, and that's why even when people say like when you're going on a job interview, like first impressions are key. Like,
Oh yeah,
first impressions are so critical, so critical.
Yeah. Despite your own inner voice telling you it shouldn't matter what you look like,
Right.
it does.
It does.
It does matter what you look like.
It does. First impressions are so crucial.
Like if this is the first time you're watching this, you're like, these guys are slackers. And you know what? You're right.
Don't tell our secrets, Juan.
Yeah, guy with the backwards cap. No, but it's there is power to it. There is power to that, and snuffing out the bullshit it takes time and
it takes a familiarity too.
It takes a familiarity
which
component.
takes time.
Yeah.
Right?
Yeah, it like you and I, we've read probably over 100 papers in our lifetime, scientific
probably
papers.
around there, yeah.
And so we kind of get a good sense of like what
what even looks legitimate, and
And
people
what
might say,
doesn't.
and then of course the skeptic would say like, oh, how do you know it's legitimate just by looking? Like, that's not enough. But it's that whole instinct that you're saying. But of course, some things can be outside of that, but that's why you have the logic to back it up.
Yeah, some things are immediately obvious.
Yeah.
But some things are like we were saying in the previous. I'm kind of regurgitating some things, but
Yeah.
the cyclical like nature of citing oneself, that's already a bad sign.
Oh yeah.
Like
You mentioned that in the last video, I think, with
yeah.
the UFO. Uh-huh.
Yeah. But it's like there are certain things that that are not necessarily taught. Well, they are taught in like writing classes. It's like don't cite yourself.
Right.
Don't cite Wikipedia. Don't cite like kooky kind of
Yeah.
like things which.
But then there could always be the exception to the rule. Like, because let's say if Einstein cited himself, I would be much more forgiving of that because he literally invented a whole area of physics, right?
Yeah, but
General
if-
relativity.
Yeah, but that means that's already something you would already have to cite something that's already been through the ringer. That's already been
yes.
fact checked.
Right,
and, like,
right.
Tested.
And I'm sure there have been several other physicists who cite themselves, but that's the key, like you said, is it's already have to have been through the whole test of whether this is bullshit or not. And many people have corroborated that this is good and true. So, yeah.
Yeah, man. Didn't think we were gonna go down this rabbit hole, but here we are.
Yeah, but we're going wherever we want.
That's why we're kind of off the cuff a little
Off the cuff a little bit.
I think we should get more gonzo as we go on, too.
I don't know what that means.
Gonzo meaning like, gonzo journalism. It's like kind of just on the beat. So people are just walking around. The journalist kind of just chronicles whatever's happening by just existing there.
Oh, cool.
And I would like it if we were not saying we should do that, but I'm saying we should kind of maybe do this as more of like the audience is getting to see what our normal conversation is.
Oh, gotcha.
Because I feel like we kind of still cater a little bit towards the audience. And I wonder if it'd be interesting to just see us just talking how we normally do. Without really considering the audience that much and just letting it be like they're hanging out with us in the room.
Gotcha.
Although I still feel like we give that sense, but
Yeah.
we still do kind of address the
Yeah.
audience a lot. So
Yeah.
leave it. Let us know if that sounds like a good idea to you. audience.
Yeah, maybe,
if you want to
maybe
be more
not.
gonzo in our approach.
Yeah, I mean, yeah, because we have similar discussions while we're chilling on the couch.
Yeah.
Or something like.
And I was getting inspired by the last two JRE podcasts that I watched with Post Malone and David Cho.
Oh, okay.
Because they were almost speaking more like it was just like they were just hanging out.
Yeah.
Didn't address the audience really that much at all.
Gotcha. Yeah. Why do you want it to be for performance? I can cry on the show.
No, I don't want to do that.
Yeah, I know. You just have to get real serious.
Yeah.
No, we watched. Funny enough, we watched Top Gun the other day.
Yeah. That was actually, it was interesting. What were your thoughts on that?
I mean, just it kind of made me think about like engines, like because like in one part of the movie, the protagonist, I guess Tom Cruise and who plays Maverick, and then Goose, his co-pilot.
Mm-hmm.
They're chasing a bogey, quote unquote, and they're trying to get a good shot. And they get caught in this. What do they call it?
I think they called it a jet flow or
jet flow
water. Or hold on, it was like a.
Let's just say jet flow.
I don't think that was it though. Jet wash.
It's like a tailwind.
I think it was jet wash.
It's like it's a jet wash, but it's like a tailwind for cars. If you when you're driving a car.
At least that's what we're assuming.
Analogous, yeah.
Yeah.
But I was like, why would you spin out of control? When that would happen, like why I started thinking like, what the hell, like why would you start?
I bet it has something to do with turbulence, because at some point for the podcast, I don't know when, I was doing some research on, or maybe it was for Twitter, I was researching wings and how wings have airflow over them, and when they have airflow over them, actually in the back you get these turbulent vortices, and maybe somehow with the jet wash they get these weird vortices or something that mess up the actual lift of the wing, and it puts it in this kind of strange situation where it spins out because of that. I would assume, because usually turbulence is a problem, right? We like laminar flow when it comes to jets and wings like that. Although you can exploit turbulence in some other ways, but it's more complicated, I think.
Yeah.
So I would imagine it has either something to do with turbulence or maybe it has something to do with the displacement of the wind. Because I think when we were watching it, I was saying that maybe it has to do with displacement of oxygen or of air, where now you have these pockets of lack of air. Because you know how when we see jets, when they are about to hit the sonic boom, they get this giant cone of air in front of them. And I imagine all that air is just pushed in front of them, and then there must be like a vacuum almost of air behind them.
Yeah.
Because it's just so much displacing so much air. And I know that jets rely on a stream of airflow constantly. So I was thinking either it's A, some weird thing with turbulence, B, it's like that displacement of air to where you have this weird vacuum left behind it, or C, a combination of the two. So,
and by vacuum, I guess you mean like lower pressure, like just a pressure differential that it creates, right?
Maybe I don't know if pressure is the big part of it, but I'm talking just a displacement of air somehow. Because when jets are moving, all that air is accumulating.
Yeah, but I'm saying necessarily those like higher pressure in some sense. Like there's more molecules of air on that.
Sure.
There's like less here. And
maybe you can analyze it with pressure somehow, but pressure might not be the relevant variable.
True, it's like an open system anyway. So I guess.
But I don't know.
Yeah, it is interesting. I would agree with you on the latter though, because I think like the constant stream. Because I was thinking, if you get caught in one of these spiraling out in a sense, you want to maintain the course. I'd imagine. So your engine can get oxygen again, because what happens in the movie is that, assuming it's accurate, the engines stall out.
Right.
The engine started stalling out, and then they lost control, and then
that to me would sound like there's a lack of air or something going through the engines, because air needs to be constantly blowing through those engines.
Yeah.
I'm pretty sure.
It's like a fish. It's like it dies if it's not moving. Like does it say that about fish?
I don't know if it's a good
like
analogy.
They're saying sharks have to keep swimming to get it's like to get oxygen to flow.
Oh, I see.
Yeah.
Through their gills and whatnot.
Yeah.
Oh, okay, maybe so. Yeah. I don't really know much about that stuff.
Assuming
So-
that all this is true, assuming.
Yeah, this could be very wrong. So please, guys, don't
Even the
take
stuff
this as
about the
gospel
sharks
at all.
could be wrong too.
Yeah.
Because we didn't really study this well enough to say that. But this is
This
this
is also
a
my
warning
first.
of physics.
This is
speculation.
No, but this is the logic. It makes what's more logical to
Yeah.
make sense. But yeah,
This is honestly a thing that physicists do too. Is like we have a lot of knowledge about physics and a grab bag of tools to choose from, but still, guys, like when we say things sometimes, especially when we're giving this warning, there's certain things we're really certain of because we've already gone through them or thought about them
Studied them.
or have looked them up,
Yeah.
whatever the way to get there was. But physicists, the nice thing about being a physicist is you have the tools to be able to come up with answers even if you don't know for sure. But sometimes that can be you actually have 2 or 3 ideas in your mind, and then you have to go down that path to explore which one's the most likely one that contributes to that.
Mm-hmm.
So with this situation, I would imagine probably it's that displacement of air.
yeah.
And then, like you said, you should try to just go through a straight path through that wash, rather than just get out of the jet wash or whatever it's called as quickly as possible.
Yeah.
But maybe that's not the way to go. Who knows?
Maybe all
Maybe
those
it's too late by that point.
Maybe all those big wigs and they get paid big military money.
Mm-hmm.
They're like, no, they're pretty sure they figured it out. Pretty sure that's
Maybe.
pretty sure that's what you do. Because it's like you do the same thing when you're spiraling out of when you get, like, for most people, this is probably what some people have encountered, which is if they're driving, let's say on a highway and it's raining,
Mm-hmm.
you'll get what's called
Hydroplane.
hydroplaning.
Mhm.
Yeah, which is your tires lose traction because the grooves on the tire they just fill up with water, and so there's no traction between the road and the tires of the car.
Mm-hmm.
And especially if you have front wheel drive and you're driving really fast and you lose traction on the surface,
Mhm.
you'll start losing essentially control. So
Mhm.
now your car is now a vector.
Mm-hmm.
Because you're just
Because you're going one direction and one direction only.
yeah.
Huh.
You're sliding on a frictionless surface now. You don't have any control over the direction of where you want to maneuver and
Mhm.
stuff. And in that situation, do you know what they tell you to do?
They tell you to.
They tell you to go in neutral.
Yes.
Yeah.
But I was trying to think why.
They
why
tell you to go
neutral?
in neutral.
Why neutral?
Because I think, well, for one, if it's like a frictionless surface, I think accelerating is not going to help you, right?
Yeah, because you have no traction.
Yeah. So
But then my thought is, why not try? Because if it's on a frictionless surface, no surface is ideally friction. No surface in real life is actually frictionless.
no,
so
true, but maybe this is why
you
they
can
tell
get
you to go
traction.
neutral. So because they know that you're going to, because I think accelerating might put you in more trouble than not.
Because maybe you add a vector now to where you can go to a spin maybe or something like that.
I think that's what happens. Yeah.
Okay, I could see that.
Yeah.
So neutral, but why would neutral help? Just maybe I would say
To
then
slow
just
down,
just
probably.
don't give it gas.
Yeah, to slow down. That's probably what it is. To get
But
you to
neutral
slow down.
won't do. But neutral then would be identical to just don't give it gas.
But they don't even say to pump the brakes either.
Yeah.
Yeah.
I imagine the same thing because if you catch it all,
You've now added a spinning.
Oh, now you're
You've
spin.
now
Now you can
added a
spin.
component to spin.
Yeah.
Spin now.
You can spin out of control. Yeah.
Yeah. Maybe
So-
just say neutral so you don't tempt yourself.
yeah. I
you
mean,
don't
because your
push the
instincts
gas.
might kick in, right?
Yeah.
Where you're just like, oh, I need to accelerate
Right,
or
right,
decelerate.
right.
But you're going to change the direction of the force. You're going to have some impulse that you have to kind of.
Right. So then in neutral, if you push the gas, nothing's going to happen anyway.
Yeah.
But neutral braking will still do something.
Mm-hmm.
So
I just
you're not
imagine they don't
completely
want you
safe.
to spin out. Yeah, it's probably better if you're one of these like car people that know exactly what's going on. Maybe you know the answer, but I imagine it's a similar scenario where you just have to get out of it.
Mm-hmm.
You maybe
Just let it ride.
just let it ride. Because my buddy was telling me, it's the same thing with snow when you're driving in snow,
Yeah,
right?
yeah. I
I
think so.
they tell you to do the same. I've never driven
Because
in
you're not
snow.
going to stop. You're not going to stop it.
Yeah, so they just tell you to like maintain course.
But then my thought would be, let's imagine this. Actually, the best thing to do would be, let's say if you're driving on ice, for example, if you can catch where your wheels are completely straight, the best thing to do would seem to be put it in reverse and accelerate and to drive.
Wait, what?
Because
put your car in reverse while you're
yeah.
on
So
ice.
let's say you're on ice, you're going straight.
Yeah.
You catch the ice.
Yeah.
And then now you're
gliding.
along for the ride. You're caught in the ice, and you're just going straight down the ice.
Okay.
But the thing is, if your wheels are straight and you put it in reverse, and then you gas it,
You're not going to catch traction, bro. You're going to just.
But the thing is, no system is perfectly frictionless.
Mm-hmm.
So if you can put it in reverse and you can catch any traction, you're going to at least slow it down to where once you crash, the damage will be minimized.
Sure.
You see what I'm saying?
I see what you're saying. I think this is a situation where.
Don't
like,
take that advice though, because it could be wrong.
Yeah. Don't sue him if you get.
Yeah, I'm trying to speculate right now.
I heard,
this is brainstorming.
babe, don't worry. I heard this in a podcast with two physicists. I got this. Got it. Just go in reverse, floor the gas, and then you back into a person.
Eigenbros.
Yeah. Cut to you. You having to pay extra insurance money because you reversed into the car behind you. So I would say refrain from.
Yeah, don't try these things.
I think that's why they tell you to go neutral, because if you do catch traction, now you're just like you're jolting into like into a situation where now I'm freaking going like I can't
But actually,
stop it.
maybe braking is even better, because at least with braking, the thing is now your tires are locked.
Yeah, I think that runs into this. Yeah, they're locked.
Yeah, so then that means now, as soon as you catch any friction, the tires will hit that friction, and then you'll just keep slowing down.
Ideally, I think some people spin out though. But I think this is where all-wheel drive is better than front-wheel drive in this scenario, because all-wheel drive, you can control the direction of the car at with everything. I think. Yeah, I mean, the best thing to do in these situations, I think, is to stay the course and try not to hit anything.
Yeah.
Because there's like a famous video of.
But how are you going to try not to hit anything if you just have one directionality? You as soon as it hits the ice patch, it's all in the ice's hands, right? You have no control.
Jump out the car.
Mission Impossible style.
Yeah.
Yeah, that'd be a good physics test question. What should you do if you hit an ice patch? Hit the brakes, hit the gas, put it in reverse, hit the gas, turn the wheel.
Well, yeah.
And then justify your answer.
I
should put that on Twitter.
Sure. Yeah, that's a good question.
I need to know the answer myself, though, first.
Yeah. Anyway,
yeah, I think we're about that time, right?
Yeah. Well, Top Gun was an interesting movie. Let's just say that.
Yeah, it's cool.
Yeah.
I mean, it was dated, but it was interesting.
Yeah, the first half.
I saw it more as an indie film because it was so strange.
Yeah, the first half of the movie was beyond strange.
Yeah.
It really was weird.
The dialogue was very cringy and the pacing was very slow not in a weird way, because movies back then had slow pacing.
Yeah.
But the slow pacing made it even weirder.
And the dialogue was just so cringy, man. Like everyone was just like you were saying, everyone was too cool.
Yeah.
Like Tom Cruise, and in one part of the movie, Tom Cruise comes into the love interest's house. By the way, shout out, she's an astrophysicist.
Yeah.
PhD.
In the movie.
Yeah. He goes in to see this the astrophysicist, and and he's like, "Can I take a shower at your place?" And he barely knows her.
Yeah.
And she's like, I don't know. Personally, if I had a stranger,
it was trying to show just how confident he was.
I
He
guess
could just go to her house and ask her to take a shower.
Yo, can I take a shower? Such a bro move. Yo, I know. He literally just got done playing volleyball with his bros, beach volleyball with his buddies, and he shows up confidently, stinking, to his date's house, and he apologized. By the way, he apologized for being late, not for stinking, not for being like, "Hey, I'm sorry.
Right.
Actually, I was playing volleyball with the boys."
Yeah.
Yeah.
Important business.
Yeah, official government business. Yeah, strange movie.
Yeah, strange movie. I would recommend it highly, though.
Because this is a weird watch.
Yeah, the latter half is much better when it gets into the dogfighting stuff. But even the dogfighting stuff can be a little bit disorienting.
Yeah, I thought I was not really as impressed by the dogfighting because I was just like,
It's hard to keep track.
yeah,
Right?
it's like the same kind of feeling I got with the Bourne Identity movies with the action sequences. The cuts are in such a way I couldn't keep track of what's going on.
Yeah.
And it honestly made me want to zone out because I just couldn't pay attention to what's happening.
Yeah, the jump cuts were like sporadic and just
When you have too many cuts, I just don't like that style because I can't focus on what. Spatially, I don't get what's going on. In the scene.
True, and
it just makes me lost.
It jumbles up the information.
Yeah.
Because they do this thing too where they cut into shots of the cockpit, and they cut to different people, but the people aren't distinct enough.
Yeah,
They all wear masks.
Yeah.
They have different helmet colors, but I forget whose helmet's what.
Exactly.
I'm just like, I don't know who is who.
They should have made it simpler. Like this guy's wearing a red helmet. This guy's wearing a blue helmet. This guy's like they show they show close up shots of like them shooting missiles. I'm like, who's shooting the missiles?
Yeah.
Who's shooting?
And it will be
what?
the same shot of the same missile fire,
Yeah.
maybe for different people.
So yeah,
So it's definitely going to be aged, and
Yeah.
you're definitely going to feel that when you watch the movie. But it's an interesting movie in the catalog of film. Maybe it's a case study on what not to do.
I liked it though, honestly.
Yeah, I liked it.
It felt like an indie film to me. I was like, this is really.
I was captivated the whole time just
Yeah.
from everything, but I was like, this is just weird, man.
Yeah, like I said, it feels like it turns into a completely different movie in the second half. Completely different movie. So
But cool.
So check it out. And yeah, leave a comment. Did you also like Top Gun when you first saw it?
Yeah.
No, but no. I guess like Terrence is saying, if you enjoy the format, then or if you feel like maybe it could be more like this, then leave a like, comment, subscribe if you haven't already. So
And stay for
Stay
the
for the
outro.
outro.
What's up, people?
what's up, people? Terrence just, like I said, he came to the realization.
Yeah.
So he's a little dejected, but
Yeah.
leave a comment if you want to see more of this, and and just like, comment, subscribe if you haven't already. Follow us on
Share.
the socials. Sharing is important. Sharing is caring. And yeah, just
Follow our socials. Eigenbros on Twitter. Eigenbros on Instagram. Eigenbros.com. And Eigenbros2 on TikTok.
And we'll see you next week.
See ya.